This is a momentous occasion for Bluewan. We've been working very hard the last few years to bring a technology to market that we believe is disruptive. Disruptive in terms of what it can bring to super fast broadband access to all, as well as what we can bring to the table in terms of mobile network backhaul, whether that's 3G backhaul or 4G backhaul, whether that's WiMAX or long-term evolution or various revisions of HSPA. We believe that today what we're going to show you is going to be quite impressive in terms of what we can deliver to enterprises, consumers, and mobile network operators. What we've done is developed a system called Fiber Through the Air, FTTA, which you'll hear a lot about today. Some of you already know a little bit about it. A lot of you are going to discover it today. And Fiber Through the Air is fairly unique in the sense that it's one of the few systems in the wireless space that can actually deliver several gigabits worth of capacity on networks. It's what we call a multi-gigabit system. And multi-gigabit means what? It means that we have enough capacity in our system to backhaul clusters of base stations that will meet the demand, the future demand for smartphones, iPads, tablet applications, machine-to-machine integration, smart grid infrastructure, everything that's happening today, that's happening now in terms of technological evolutions, both from an infrastructural perspective, a public sector perspective, and a consumer perspective. And the key thing about this multi-gigabit system is that it just doesn't have all this capacity. We've actually developed an end-to-end system that goes from where the fiber is, which may be miles away from where you're trying to deliver service, and basically teleport that fiber to locations where fiber can't go. Why? Either because it's too expensive to deliver fiber in that location. We got to bear in mind that some of the numbers around fiber is that it costs around 70 pounds or 100 euros per meter. So the return on investment on fiber deployment is highly dependent on the number of people that are going to get that fiber and subscribe to that service. So there's a direct correlation between population density, right, and fiber access. And if you live in remote areas or rural areas or even suburban areas, you may not get fiber because the return on investment of deploying fiber for a service provider may be decades. We were going to focus on the business model. We want to transform the business models of what it means to deliver super fast broadband to the masses, right? And by the masses, I mean consumers, small businesses, big businesses living outside the metropolitan areas. We've developed this technology with very wideband radios, these radios that carry a phenomenal amount of capacity. And we've developed customer premises equipment, customer equipment that allows us to harness that capacity, right, and unleash bandwidth inside the home or the business. So we are one of the few wireless systems in the world that can actually deliver up to 100 megabits per second to the premises. 100 megabits per second is basically what the most advanced Virgin Media broadband service can offer, the most advanced France Telecom Orange service bundle can offer in terms of speed. The point is that they can use our technology to deliver that 100 megabits without having to trench further fiber. The central transmission hub is where we integrate with the fiber optic connection. It's also where we take other feeds of data that we want to transfer to consumers and businesses, like satellite broadcast television, like aerial TV. We convert all of that power, harness it, right, combine it, and transfer it to our radios to then cast it wirelessly across a large coverage sector. We emit from here, we transmit to a relay station, from that relay station cast over a north to south angle on Paris. One of the drawbacks that people keep talking about wireless systems is around latency, or in common terms, ping. In even more common terms, the amount of time it takes for your client or your game server or your game client to connect with the server and the other players. And the longer you're paying, the less likely you're able to play online. This brings me to a point about solutions that exist today for providing broadband in rural or remote areas. Satellite is often proposed as an option. The problem with satellite is that the ping is usually too long. The latency is too long for us to enable modern day applications like gaming. So even though satellite is viewed as a solution of last resort for broadband, it's actually, for me, an unacceptable solution because I cannot do what I want to do with satellite broadband. I cannot play World of Warcraft, not that I have time. I cannot play Gran Turismo 5 on my PlayStation. So I cannot have a VoIP or a voice over IP conversation. That's why FTTA exists, because the latency that we have here is minimal. We don't have to go to the sky and wait for a satellite to return the data to us. Everything's happening terrestrially. Combine that with other modern day applications like over-the-top services, such as Apple TV, right? More and more consumers are straying away from broadcast content and moving more and more towards personalized over-the-top content. We see that in the United States with services like Hulu, BBC iPlayer in the UK, the upcoming Netflix service that's migrating from the US to the UK. There's more and more such services that are being delivered to consumers that are consuming IP bandwidth, right? In order for that IP content to be delivered in high definition, it's going to require a lot of bandwidth, generally about 5 to 6 megabits per second per stream. So if you don't have access to that kind of bandwidth, you're basically being cut out by all of this new content that's being generated. We can take this even further and think about other modern day applications or future applications around tele-distance learning or teleeducation, telemedicine, where the people who need specialized care the most, right, who are living in rural areas, are not able to physically access the right skills or the right doctors, right? Technology is being put into motion to help those people in remote areas, right? However, the condition is that they get access to a broadband connection, and not just a 2 meg broadband connection, but a 10, 20, 30, or 50 meg broadband connection if they want to do an HD quality video conference call with their specialist, right? So these are all things that we've taken into consideration in terms of how can we cost effectively deploy those kinds of bandwidths to those consumers that need it the most, right? And create a business model that'll invite or entice operators to get in there and deliver those services. We want to show that the consumer who's using a fiber through the air system is not compromising. It's not a compromise. It's actually just as good, if not better, than what you can get in the city. One of the things that people always ask me is, aren't you guys just like a super WiMAX or something like that? And I always smile when I hear that question because we're really not. One of the things that we got to realize about WiMAX and the promise of WiMAX as a technology for providing broadband to rural is that broadband operates at a very low frequency spectrum. It's nice because that means that WiMAX ostensibly goes through buildings and you should be able to get reception without a dish on your house. The challenge with that in any case is that the amount of spectrum that's available in WiMAX is a very small pipe. We have 3 gigahertz of bandwidth in our spectrum, which in turn allowed us to develop a radio that's 10 by 10 centimeters. And that radio is what generates, on average, about 2.6, 2.7 gigabits of capacity. All right? So if you put a few of those on a central base station, you're quickly getting to 12 gig. WiMAX cannot do 12 gigabits worth of capacity. WiMAX as a mobile broadband technology has, I think, definitely, it's been decided as a mobile broadband technology has kind of lost the battle to LTE in terms of what operators are going to invest in. I think in terms of fixed wireless access, WiMAX still provides, some advantages, great propagation qualities. The only problem that it has really is that it doesn't provide enough capacity to end users. So where the end user demand or requirement is less sophisticated, right? WiMAX still has a play. But when we're looking for super fast broadband applications, then I think that we have to look beyond WiMAX and hopefully look towards fiber through the air as an alternative. So the actual frequencies that we use are normalized by ETSI. So there's no, there's no further standardization in terms of the spectrum required. The frequencies that FTTA uses are normalized frequencies. Governments around the world have ratified the use of 40 gigahertz. We're now kind of talking to a lot of government authorities, national regulatory authorities, to start auctioning 40 gigahertz. The reason why it hasn't happened so far is that there has been no equipment to this day that leverages that spectrum, right? So in some cases, we have basically a time to market advantage here. We're talking to a lot of different government organizations. I mean, whether it's in France or whether it's in the UK. With the UK specifically, as you're aware probably of the sort of Digital Britain initiative and the Broadband Delivery UK team, the BDUK team that's been tasked by Jeremy Hunt and Ed Vaizey to essentially look at solutions to provide superfast broadband around the UK, right? In areas, in not spots and slow spots, so to speak, where there's limited broadband. So we've obviously been in conversations with BDUK on briefing them on our technology. They're very interested in what we can bring to the table, especially in terms of how it differentiates with other technologies that are out there. We've had conversations at ministerial levels, whether it's with Ed Vaizey's team or whether it's with MPs like the MP of Penrith and the Borders, so Rory Stewart. If you know, Rory Stewart is a very, very heavy advocate of superfast broadband, and he has a clear vision for what Cumbria should be receiving in terms of superfast broadband. And one really interesting thing about Cumbria is that it has a very intense broadband activism. There are a lot of people here that are clamoring for superfast broadband. The challenge with Cumbria is that economically, fiber FTTH is a challenge. They're looking at different ways, like how do we get the farmers to dig their own trenches, for example. But ultimately, where is that source of data going to come from? It still needs to come from a major fiber point of presence, right? Whether it's in Manchester or somewhere further. So how are we going to get that bandwidth to them? So we're having different discussions at different levels. We obviously are very keen to get involved in the BDUK trials, whether that's with Cumbria or whether it's with Yorkshire or Herefordshire, or Shetland and the Islands. Those are all great projects for us to demonstrate our technology. In order to do that, we'll be obviously looking at partnerships in the UK to execute on those trials. I mean, we got to realize the UK situation from a budgetary perspective, right? Just went through a fairly severe and critical spending review, right, at the early part of, the late part of fall last year, which had a big impact on what the execution bandwidth is going to be for the UK government on superfast broadband. So, if you compare that to, for example, the tens of billions of Aussie dollars that are being spent in Australia for the Next Generation Network Plan, if you're looking at the billions of dollars that are being spent by the US government, it's a bit of a different number, right? So I think that it's even more important for us to have the UK government kind of understand the value proposition we bring from an economic perspective, because they're really going to have to do more with less. If you think about it, it's about 30 billion pounds to deliver fiber to the home to each and every UK resident, right? So if you, 30 billion pounds, and we've got British Telecom that's, looking to spend 2.5 billion pounds, there's a gap. And there's a market failure somewhere, because the failure of the market is going to be around, well, I'm not seeing an ROI, a sufficient ROI as a service provider to deliver broadband to this area, so I'm not going to do it unless the government intervenes. So the strategy that the UK government is putting in place is, putting in place private-public partnerships to try and trigger some investment. I think that those relationships need some lubrication. That lubrication comes from different kinds of economic models. We cannot rely on a fiber to the home or fiber to the premise economic model. If we can introduce new dynamics, new equations, then maybe we can accelerate the delivery of that broadband.